So like you said, I'm Dave. I work in infrastructure at Spotify. And I want to talk to you a little bit about a kind of similar transition to what you just heard about, but from Spotify's perspective and on a slightly kind of shorter timeline. So first, I'll give you a little bit about Spotify. You've probably heard of us as a company. You know we're not an infrastructure company. We don't produce much open source infrastructure. Our product is really highly personalized streaming music. Some of you have probably also heard a bit about our org structure. We've released a bunch of videos and blog posts and things about the way we structure our company, but haven't talked nearly as much about the technology that powers it. So I'll still touch on that org just a bit for those of you that haven't seen those things. We're structured in multiple business units that each focus on their own topics, like most companies. And then we have a reasonably large, like few hundred-person platform organization. And that platform organization is split up into data, client, and backend, which is the part that I'm from. And we've been focusing a lot on figuring out how to have level up what that infrastructure team does. And instead of having a team that focuses on core infrastructure things, really move closer to music, closer to things we produce to our customers, because we don't want to be a company that invests very heavily in infrastructure. That's not really a thing we do. So I want to tell you about this transition we did and these multiple stages and how we've looked at it as really the way we're trying to do that and shift our company to be able to focus significantly more on what our business is. So initially, I'll say a few years ago, we were running entirely in our own data centers, on our own hardware, on our own switches, et cetera. We had a bunch of people within that couple hundred-person platform org whose jobs it really was to rack and stack servers, to kind of take them out of boxes, put them on racks, make sure the switches all worked, things like that. We also had a whole bunch of our own proprietary software. Initially, we might have been doing simple things like PSSH to deploy across all of our boxes. We were an early adopter of Docker, so we ended up building our own Docker container orchestration system we called Helios that we open sourced. We built our own protocol for most of the message interactions across our backend and with our clients, because we had a bunch of issues with HTTP1 and some of the things that existed when you first started streaming music close to a decade ago. So we ended up having to have a very large platform team that owned a bunch of things that have really nothing to do with delivering music to customers. So the first thing we did is, much like you just heard, we wanted to move to cloud, and we have, as of early this year, shut down all of our data centers and are fully running in public cloud, but still with much of the stuff I just told you about. Still using our own protocol, still using our own container orchestration, all of those things. So that really takes us to this next step, which the slide says today, but really we're kind of somewhere in between those two places. Once we had moved to cloud, we decided that we really want to keep leveling up and keep moving the focus closer to music and farther from infrastructure. And we kind of called that cloud native, for lack of a better term on it. So I'll give you a little bit more about the first few transitions, and then I'll dive into that today part. The thing a lot of people ask us about is how we actually did this move, because it was really about 3 to 4 years total from when we started talking about it, but closer to a year and a half of like truly focusing on it, moved out of our own data centers completely into public cloud. And a lot of people have come to us saying that that's crazy, and they're very impressed with how quickly we did it, things like that. Really, all we did was just set a goal of closing our data centers. So we made this a much simpler kind of agile transition. And instead of saying, let's move to cloud, let's be cloud native, let's do everything. It was really just do everything we can to close our data centers. And that meant many shortcuts, many things like I talked about before, where we kept our proprietary infrastructure, but we just moved things to work in the cloud. So for backend, that was much easier. We could just forklift things. We could take VMs that were running on our hardware and run those VMs on hardware in the cloud. And that's largely what we did. We didn't move to manage storage. We didn't move to manage load balancing, et cetera. We just moved our stuff. On the data side, this was much more interesting, because it's much harder to just take a 3,000 node Hadoop cluster and move it to 3,000 VMs. So there we ended up creating a bunch of interesting tools for migrating to cloud native data pipelines and using some ephemeral Hadoop, but much more than that, we migrated actually to using our cloud providers' built-in like managed data pipelines. So at this point, we're completely in the cloud. We've done all that. We kind of call that part done. But of course, like I said, we're not done. This is really, to me, the kind of much more fun part. We started looking at what issues we had once we were in the cloud, once we weren't worrying about racking and stacking and the things that you typically hear about as reasons to move to the cloud. And here, we had all of our proprietary software, but we also ran into a bunch of things like we weren't very cost effective. People say, you move to the cloud, it's going to be much cheaper. Well, if you just kind of blindly move to the cloud as quickly as you can, it might very well not be much cheaper. Then we had some other issues, like a lot of the on-premise provisioning tools we had didn't expect things to happen very quickly, because when you get a new machine, somebody has to physically rack it and stack it. So some of those tools took 30 to 40 minutes to accept a new machine. And now in the cloud, you click a button, you might get the machine in a minute or two, maybe less. But it still takes close to an hour or at least 40-ish minutes for that machine to be live and running all the software you need. So again, kind of not getting much of the benefit of being in the cloud. So that's where we kind of coined this cloud native term internally, and weren't relying too much on what the rest of the industry called cloud native. We kind of developed our own definition and our own focus on what that meant to us. And we kind of broke it down into these 4 points. The biggest one for us is probably resiliency. And a couple big differences we noticed upon moving to the cloud was that there were many, many more failures in cloud, which is kind of unexpected to people. But the mean time to recover and the time to kind of get back up and running after those failures was much, much smaller. So you may have quick outages of a few VMs or some small piece of your network or some managed service that we never had in our data centers before. But unlike our data centers, when something broke, like a switch, we had to send somebody out there, replace the switch, get it fixed. It was, let's say, hours, but it may have been much more than that. In the cloud, these things come back in minutes. So we had to shift all of our models and all of our kind of infrastructure tooling to expect constant failure and very quick recovery. So something like shift all the traffic from North America to Europe was kind of a pointless thing to do, because by the time you shifted all the traffic, North America would be working again. The other obvious thing is operability. Because we're not operating all of these boxes, it's much easier for us to run this stuff. And on the other hand, like I said, because we had tools that would make things take 30 to 40 minutes that in the cloud take less than a minute, we had to adjust all of our operations practices around those things. Observability is a clear one that comes out of those first few, because if things are so rapidly changing, we need a way to view it, and all of our existing monitoring tools that rely on like a specific VM existing for a year emitting metrics don't work. And we added agility because we felt like if we can nail all those other 3, the real thing we get out of that is a much more agile organization being able to do things much more quickly across the company. The 2 that didn't make the top 4 but are kind of almost as important, obviously I mentioned cost efficiency. But the other thing we talked a lot about was open source and community interaction. And I call it interaction for a couple of reasons, but one thing is we wanted to rely on as much open source and community infrastructure as we could, because we wanted to be able to work with the rest of the community and not just specific providers on all this stuff. And also because we wanted to contribute back, because we did have this large org. We did build all of these things ourselves. So we wanted to be able to give that back to others. And we summarized all of those points really in this one sentence that I put on a lot of slides last year. You've probably heard of people referring to servers as pets and cattle. Well, we said the kind of next step is that you don't care about the cattle either. You're just worried about the herd. As long as you have, I don't know, 50 instances and they're delivering all the traffic, you don't care if they're named instances or numbered or whatever. You just need it working. And this is very close to what things like Kubernetes do, where everything's just a pod and it runs and you don't care where it runs. And because we were talking about cloud native, we started looking at the rest of the world, of course, because like I said, we talked a lot about being open source. And that's where we joined the Cloud Native Computing Foundation, and we started getting really deep into a lot of the technology and the events and the things they do there. We really liked the Cloud Native Computing Foundation because it was a collection of companies that maybe weren't in the same place as us, but were solving very similar problems as the ones we were. And almost every major infrastructure provider across open source or public cloud was in the foundation, and they were really trying to figure out how to make this the most effective thing for all of the end users. So it's a great way for us to kind of come in and say, on the one hand, we don't really know what we're doing, let's figure this out together. And on the other hand, hey, here are our concrete goals, let's figure out a way that you can help us solve them together. So I'll touch on Kubernetes just because that was our first obvious big transition, and that's the thing people usually think of when they look at CNCF, because CNCF was originally founded as a home for the Kubernetes project. Like I said, we were an early adopter of Docker containers, largely because we needed something that was better than our manual deployments of Debian packages across all of our servers, and we built our own container orchestrator. We hit all the issues that kind of everyone talks about, like we couldn't keep up with the rest of the industry. There were features that our feature teams wanted from our container orchestrator that our platform team couldn't deliver, et cetera. But when we first started building Helios, it was the only thing that really worked for us. Kubernetes clearly can do everything Helios does and has a whole bunch of features we don't have. So it was an obvious thing for us to migrate to. I'll talk a little about our migration process and how we approached it. We, again, very similar to the cloud migration, wanted to be really focused on specific things at any given time and not to turn this into a big monolithic, like the goal is 100% of Spotify running in Kubernetes with all the perfect Kubernetes tooling and replacing every one of our internal things with Kubernetes native concepts. We took this as very simple, concrete steps. I mean, the first one is just running a container in Kubernetes, actually serving traffic. It seems really trivial. It seems like something obviously Kubernetes can handle. But for us, we needed to learn what Kubernetes looked like in Spotify, what it meant for it to interact with our proprietary service discovery system, what it meant for a container in a Kubernetes cluster to serve traffic using our proprietary protocol. And on the other hand, how to integrate it with some of the kind of open and provided things we have, whether it was our cloud provider or we use Puppet a lot, things like that. So that taught us a lot about Kubernetes at Spotify. Then once we got into multiple services, that was really where we had to start thinking about things like multi-tenancy. And that was really interesting because we had to figure out how to make it so that one team couldn't accidentally bring down another team because both of them were kind of new to Kubernetes. And not that people at Spotify are trying to take down each other's services, but if you're new, you'll accidentally run the wrong command and hopefully not take down someone else. Then we got into just letting any team come to us and say they wanted to do it. Everything was still highly manual at this point, but it allowed us to really gauge interest across the organization and see how many people really wanted this to know if we should actually go any further. But it also taught us a whole lot because now instead of us cherry-picking services, we had completely random different people with very different requirements coming and saying, I want Kubernetes because of auto-scaling, or I want Kubernetes because I think it can provision faster, or whatever. I want Kubernetes because it can set concrete resource limits, whatever Kubernetes feature they saw, and we had to figure out how to make all that work well. Then we got into the really interesting parts. We started running much more critical things. Like we picked 2 very high traffic, very critical to Spotify services that we wanted to run in the cluster. And this was really for us to understand how Spotify could handle some of these extremes. There's this concept we've been kind of pushing a lot of trying to do an easy thing first, but one of the hardest things second, so that then once we do everything else, we can understand that the really hard thing also works. And this was exactly that. This was kind of find a really hard thing and then do it. And then the last 2 steps were really just about making this possible for everyone. Making some self-service tooling so that it wasn't nearly as manual as it was when we had volunteer services. And then the last thing, we have this thing called the golden path, which is effectively the way that we document to the rest of the company how you create a new service from scratch. And so this just meant Kubernetes being the preferred and eventually only way to run containers in production. And we actually hit that milestone on Monday of this week. So as far as migration takeaways, really, I would say from both of those migrations, even though I took this slide from a conversation we had about the Kubernetes migration, the biggest thing for us was making this very concrete about the goal we're hitting. And at every stage, both in the cloud migration and the Kubernetes migration, we would find a dozen things that weren't required for that goal, but also potentially a blocker. For example, how do we manage secrets in a Kubernetes cluster when we have, again, our own proprietary secret management system that worked fine on VMs? And this wasn't the kind of thing we needed to build the perfect solution for before we could run 3 services in the cluster. So at that point, we made a manual hacky thing that just worked and was secure enough for our secrets. But before we hit a later step, we actually built the full solution that worked. I think many companies that we've talked to at conferences like KubeCon have said once they hit something like secret management, they went off and built the full solution for it. And that meant that they never really get to like the first or second step because they spent so much time on the kind of pre-first step things that on making them all perfect that they never do that first service or 2. So aside from Kubernetes, the other really interesting things we're trying to do, Hermes is the name of our proprietary protocol. It's based on 0MQ. It effectively is protobuf running over 0MQ. It was amazing for us back when our best other option was something like HTTP REST. Now, like same with Kubernetes, there's an endless list of either standards or open source solutions that are as good or better and moving much faster. So we're having a bunch of issues with it. Things like our cloud provider doesn't have really interesting layer 7 features for Hermes, since we're the only ones that use it. Third-party tooling doesn't support it. You can't get Wireshark traces on a proprietary protocol, things like that. So we're switching as much as we can to gRPC. For those of you that don't know, this is the gRPC mascot. This is a dog named, golden retriever named Pancakes. And we made a custom logo of him with listening to Spotify. The reasons that we love gRPC is really that it provides all the things that Hermes never really did. There's tooling for message integrity. There's a lot of resilience tooling, things on retries and hedging, and there's a lot of interesting security work that is just built into the core libraries in almost every language. But probably the coolest thing for gRPC isn't just that it uses protobuf, but that it relies on proto for schemas for generating clients and everything else. So you can have one short proto file as the strict contract between clients and all servers. And that solves a big problem for us because with Hermes, with our own proprietary protocol, everything was defined in code. So for a very popular service like track metadata, we might have 100+ different implementations across the company of the client for it, and they might expect slightly different things because the person writing it didn't know that, I don't know, track ID was a 64-bit GUID instead of a 128-bit GUID or something like that. Whereas here we have one simple short proto file, and it can generate a client in almost any language. And that has a bunch of other benefits, like if we are starting to work with some partner that uses a language that we don't, we can just generate a client for them in their language instead of having to build a whole Hermes library for them in their language. So aside from those things, we get into some really interesting things. If we're in Kubernetes and we're running most of our traffic on standard protocols like HTTP2 or gRPC, we can use some really interesting other tools that are in the same space, like Envoy is one of my favorites. For those of you that don't know much about Envoy, Envoy is a proxy. You can kind of think of it as Nginx or HA proxy, but much more dynamically configurable. And it was built at Lyft, and then they open sourced it, and now it's kind of taken over the network routing world. I think all three major American cloud providers, Amazon, Microsoft, and Google, have announced that they have managed services that are based around Envoy, and many companies have been talking about how heavily they're depending on it. I think eBay announced right around KubeCon last year that around 50% of their global traffic is now terminated by an Envoy proxy. So we have a whole lot of goals of using Envoy for things like that, and it's been going really well so far. We started migrating our custom-built perimeter services, which are a combination of Nginx, HA proxy, and a bunch of custom tooling, to an auto-scaling cluster of Envoy proxies with a relatively thin layer of configuration around them, and that's doing almost everything that all of our custom stuff before did, and it's been really good. But probably the most interesting thing about Envoy, aside from its actual functionality, is the community around it. All of the companies I just listed have people that are kind of constantly working on it, but also always happy to work with us to help us with it. And that's been the most amazing thing about it. Just getting support from this community has been extremely easy and extremely quick. And the last kind of shiny tech thing I'll touch on is service mesh as a whole. I'm using Istio's logo, but just because I like their logo. For those of you that aren't very familiar with service mesh is a concept where you can put a proxy in front of every service you have, and then instead of worrying about things like authentication and message integrity and routing and service discovery in every service, you allow the proxy to worry about all that for you, and you can have a control plane that controls all of those, and you can make a central decision like drop all traffic if user equals Dave, and then deploy that across your whole all of your infrastructure just by sending a single command through the control plane to every proxy. And for us, something like a service mesh would be extremely valuable for exactly those types of scenarios, for interesting traffic routing things, for security across the back end, for things like mutual TLS. So we're looking very heavily at that. And then I'll throw this slide up one more time because I'm also a Cloudnative Computing Foundation ambassador. So whenever I go somewhere, I try to talk a little more about them. And almost every tech thing I just mentioned is either a project at CNCF or something that CNCF community is very strongly driving. We're very heavily looking at what other things are in this community and what other things we can really benefit from, especially in the security space, but I mentioned monitoring as well. We have our own custom time series database and our own custom dashboarding tooling. We're figuring out how to replace that with something that will work at scale but not be our own, but there's kind of a very long list of other things, and we're constantly looking for other teams and other companies that would be willing to partner with us to build those things and to make them kind of work better for us. And yeah, thanks.